Alright, so I think this is recording. Let's take a look at this problem. We're using the law of sines to solve this triangle. I know to use the law of sines because I'm given a pair, the measure of angle B and the length of B. I notice that this is the side-side angle case, often referred to as the ambiguous case, because we could have two triangles as a solution, one triangle or no triangle. So let's see what we have here. We've got 12.6 degrees, opposite it 2.9, and this 7.2. So I compare this 2.9 to 7.2, and I see that it's not longer. If 2.9 had been larger, that had been longer than 7.2, I'd say there'd be exactly one triangle. Um, so I don't know if there's going to be two triangles. I suppose there could be one. I don't know if this is going to be a right triangle. This 2.9 to me looks to be kind of short. So let's see what we have here. Let's find the height of this triangle. Let's take this left right triangle that's formed here, this hypotenuse 7.2 times the sine of 12.6, and that'll give us the height of this triangle, and then we can compare it against this 2.9. Alright, so I've got 7.2 times the sine of 12.6, 1.57. Okay, well, the 2.9 does cover that. So there's going to be two triangles in this problem. There's going to be two solutions. Alright, so let's jump in and find the first triangle. We'll start with finding the measure of angle C. So we'll have the sine of angle C divided by the length of C, and that's going to be the sine of 12.6 divided by 2.9. Alright, so to find the measure of angle C, we'll take the inverse of 7.2 and 12.6 over this 2.9. Now, there are two angles that have this ratio, one in quadrant 1 and one in quadrant 2. The calculator is going to treat this like a function, not like a relation. Even though we know there's two angles that satisfy this relation, the calculator is only going to return one value. We restricted the range so that it would be a function. The calculator is only going to look for angles between negative 90 and positive 90. Well, really between 0 and 90, because we don't have negative angle measures inside triangles. So I know that this is going to be an acute angle, but I also know that the calculator is not going to give me a second angle measure that's the supplement of this angle as another solution. So if I go inverse sine of 7.2 times the sine of 12.6, close that parenthesis, and 2.9. So I know this is going to be an acute angle. And there it is, 32.79. I know that there's another angle that the calculator didn't return 147.21 in quadrant 2 that also has the same ratio. See, this inverse sine could have also equaled 147.21. We'll save that for when we're solving the second triangle, though. All right, so now I have two of the three angles. So the third angle can be found by knowing that these three angles have to add up to 180. I think they refer to that as the triangle angle sum theorem from geometry. 134.61. All right, so let's find the length of A. So we've got the sine of this angle that we just found for A. And our known ratio well, I guess from our ratio from the given information. I always try to use the given rather than what I've calculated in case for some reason I have an error in my previous calculations that hopefully it wouldn't follow through, but it probably would. So don't forget to close that parenthesis and then divide by the sine of 12.6. So this length, at least rounded to 2 decimals, is 94.64. So there's one answer. Now, like I say, there's a second triangle that exists. And when we went to the calculator to take this inverse sine, the calculator didn't tell us the full story. $147. The sine of 32.79 is approximately the same as the sine of 147.21. Okay, so like I say, this 0.5 this ratio was approximately 0.54, at least at 2 decimals. So both of these angle measures have that same sine ratio. Now, since this C is different, then we're going to have a second A value here by taking 180 minus the sum of the 12.6 and this other angle, 147.21. Boy, this is not writing well this morning. So that's a length, it's not a degree. Or no, excuse me, it is a degree. Now I want to find this length. And I'll take the sine of 20.19. Now the given length and the given angle, my original pair of B, that doesn't change within the problem. So this second triangle, this angle B and length C is the same in both triangles. I can't change what's given. Those are fixed. They'll say that these are fixed values. So thought I had, there we go. Instead of this 134, now I'm using this 20.19. So this length, 45.88, at least to 2 decimals. And then, like I say, that has units of length. It may be miles, inches, feet, centimeters, whatever. All right, so I think we're done because in the first triangle, we found the measure of angle C and the measure of angle A and the length of A. And then in the second triangle, we found the same thing, the measure of angle C, the measure of angle A, and the length of A. Hey, I hope that helps, and I'll talk to you later.